We are recording.
Okay, so we chose chapter 6.2, which is about trigonometric functions using the unit circle approach.
So for the history of the unit circle, this mathematical concept's been around for a long time. It dates back to the second millennium BC with Egyptian and Babylonian mathematics. And these astronomers used angular distance measured on the celestial sphere to detail stars, how planets moved, and like the mathematics behind solar and lunar eclipses. Trigonometric functions were popular in the Gupta period of Indian astronomy, and their use continued like through the Islamic mathematics in the Middle Ages. Additionally, Hipparchus was the founder of trigonometry, so he studied the angles of the sides of triangles to find the relationships that form the basis of sine, cosine, tangent, and other functions. And Chinese mathematicians emphasized using spherical trigonometry and astronomical calculations in calendarical science in the Song dynasty. And a mathematician used spherical trigonometry to improve the calendar system and Chinese astronomy, like so in relation to how we perceive time in the calendar.
So the unit circle has a lot of uses in the real world. So for example, it can be used in the military when using sonar or radar equipment. So it can help determine where a circle plane, on a circle plane where an aircraft is located, and help the sonars detect incoming ships under the water, or tell a submarine where the coordinates of the ship above it is. And architects can also use the unit circle when curving surfaces in building materials like glass and steel to find the heights of buildings or create dimensional objects to use in buildings. And it can also be used when like cutting a circular shape like pizza.
So our extension topic was Euler's identity or Euler's formula, which is E raised to the I times pi power equals -1. And this is derived from a formula that we've studied in Trig, which is E to the ix power equals cosine x plus I sine x. And this is showing how it's derived from that. And so this identity describes two equal ways to move in a circle, and particularly imaginary growth on a circle. So these two pictures kind of show how a circle is like formed through Euler's identity by traversing a circle, and so it's showing how the formulas are used in that way. And then so multiplication is the transformation used, which changes the e to the I pi power, and it rotates as you keep multiplying it as it grows, and so it rotates 1 unit each time for pi units of time, and the pi is like showing that it goes around the circle because pi is 180 degrees. And then e to the I pi power means that you start at 1 and you rotate halfway around the circle to get to -1, which is like the x value once you go 180 degrees.
So for our model, we made a Ferris wheel on Desmos. And the angles each line makes is equivalent to the angles on the unit circle, so like pi over 6, pi over 4, pi over 3. And at first we wanted to make those lines like by graphing like theta equals that angle with polar coordinates, but because Desmos didn't let us do that, we converted the polar equation into rectangular. So because we knew tan theta equals to y over x, which is y over x would be the slope of a line, we did tan theta for each of the angles we wanted to use and made that a slope of each line.
Okay, thank you for watching.
Thank you.
Thank you.